Hi guys. Hi Sahana. Yeah, tell me.
Sorry, I couldn't finish the test. I'll finish it this week.
Finish it. Okay. Whenever, ma, whenever possible, but please don't miss the test. Can we get started, guys? Okay, I think that's it, right? This class. Shri Charan, how did you join this group? Shri,
Um, it's like what is said on the email.
it said on the. Oh, I see.
Is this the wrong time?
It is the right one. Pre-calc, right? We are good. Are you back from India?
Yeah.
Did you have
Came
fun?
back. Yeah.
Nice. Can we go ahead, guys? See, Ma, please you have to be on the videos, okay? At least that's the social etiquette I am expecting and that's required out of. Then only we'll have accountability, guys. Okay, let's go ahead. Charge போடுங்க எடுத்துட்டு வாங்க. 1 second, guys. Okay, can we get started? So last week we started discussing linear quadratic functions, right? So we'll continue with that. We'll continue with linear quadratic functions. You all know that in a linear function the rate of change is a constant, right? Right? Okay.
Yes. Yeah.
Okay. So let's say this is the average rate of change. What is the rate of average rate?
0.
Okay. Yeah, that's right. That's what I wanted to know. Rate of average rate of change means the second difference is what I'm asking. This we already know. Okay, I can make it bigger, guys. Actually, where is Akshata? She also forgot. Oh my god, so many of you are forgetting, I think. Thanks, really thanks. 1 second, guys. Okay. So, Hana. 1 second, guys. I'm just adding everybody. Okay, let's go ahead. Now, if it's a linear function, okay, for quadratic functions, what do you think about it? Quadratic functions. How can the average rate of change be? How can the average rate of change be? about the graph, guys. If you think about the graph, it becomes very easy. What can be the average rate of change? Okay, let's think about the graph. Shall I show you the graph?
The 2.
What is it?
Is it like the 2 or like A?
Sorry, Sri Charan, I'm not getting. What is it?
It'd be like whatever the A is.
Whatever the A is. Okay, this is a linear function. Okay, linear function can be like this or this. So the rate of change is there. The rate of change is always constant over equal length intervals, right? So the rate of change of average rate of change is 0. So we understood that. Okay. In quadratic function, it's going to go like this. Quadratic function, it's going to either go like this or it's going to go like this. So what do you think is the average rate of change between these 2 points or between these 2 points? How do you think the average rate of change is going to be? Either it can be increasing or
Decreasing.
yep, either increasing or decreasing. But you know what? One second. The rate of change of average rate of change will be how? Rate of change of average rate of change. So rate of change of average rate of change, that is the second difference, will be rate of change of average rate of change will be second difference will be constant, guys. Okay, let me show you how this happens. Let me show. This we have studied earlier, so I'm a little off what is causing the problem, but let's see. I want to show it to you so that you don't forget as well. Let's see. I want a nice table. Hold on. Okay. So I'm going to give you a linear function and a quadratic function. You can let me know which is a linear function, which is a quadratic function, and I'll show you what I mean by the first difference, second difference, third difference and stuff. Okay. Let's see. How about this? Okay. Let me go ahead and copy this. I don't know if I can copy it here. This is good. Do you see, guys? Let's understand. There are two x and y. Okay, input, output. Okay. Now, you're given the input output values. Okay. Now, what is the slope? First difference is what? 5 minus 2, 8 minus 5, 11 minus 8, 14 minus 11, 17 minus 14. That is the first difference. It's also called the average rate of change. What is this? What is the second difference? 3 minus 3, 3 minus 3, 3 minus 3, 3 minus 3. It's 0. So when you plot it, let's plot it and see. 0, 2, 1, 5, 2, 8, 3, 11. Okay, they did not give the other side, which is really sad, but it's going to be like this. Make sense, guys? So the second difference, rate of change of the average rate of change. Make sense? This is sometimes called the second difference. This is called the first difference. Any questions? This is a linear function. But as I said, right, if you look at it and really digest it, then you'll not forget. Actually, we have discussed this earlier as well. So that makes me a little hard to digest, but yeah. So let's see. You know the function equation is, here the function equation for this one. Oh my god. I can't paste it. Looks like 3x plus 2. The function equation for this is 3x plus 2. 3 is the slope, rate of change, average rate of change. 3 is the rate of change. Okay, 2 is the y-intercept. You know that. Now let's go ahead and erase this part. I'll erase all parts. I'll erase all of it. We don't need it. Okay. Now I'm going to go ahead and give you quadratic functions examples. Let's see how that works. What happened here? Let me write down what is this function. Y equal to 3x plus 2. It's a linear function. First difference is the same, right? Second difference is 0. This is a quadratic function. Oh, sorry guys, the previous one when I graphed it, right, I thought it was a quadratic function. Only this side would have been existing. I said, hey, they did not give the negative piece. That was not a quadratic function. I'm so sorry. Okay, I was in a different world. This is a linear function. Okay, for the second graph, 0 comma 1, 1 comma 4, 1 comma 4. Oh, again they did not give x square function. They have given, but they did not give the left side here. Oh my god, I wish I had the left side too. So basically it's not exactly y equal to x square, so approximately. Let's do slowly then. 2 is 9, 1 is 4, 2 is 9, and then 3 is 16. So something of this sort. Okay, and then it will go this way, that they have we should have added it in here. So for a quadratic function, do you see the first difference either increases or decreases? So they have given this part of the curve. They have given this part of the curve. You see, if you take 2 points, right, definitely the slope is increasing. See, it's increasing. Right? Now can I ask you one question? Is this part of the curve concave up or concave down? Is this part of the curve concave up or concave down?
Up. Concave up.
If it is increasing, it's concave up. If it is decreasing, okay, let's come there. Okay, let's come there. Okay, let's come there. Now I showed you for a linear function, first difference is the same, second difference is the same for a quadratic function. Now there are more things where I want to tell you. Okay, how about this? Can you tell me what type of a function? Let me enlarge this. Let's see this type. What is this function? Can one of you, meaning can all of you see and tell me? I'm going to go to concave up and concave down in a minute. Wait. I can erase all of this off. How about this? What type of a function is this? Give you one more. What type of a function is this? There are two functions I've given. Tell me what type of function are these? The first function is what? Second function is what? Don't worry about concave up and concave down. We'll analyze in the quadratic function about it. First, let's differentiate a linear and a quadratic function. Then we'll get there. Did you get it, guys? What type of functions are these? Yeah, that's right. Okay, now let's see. The first one is, immediately I would calculate the first difference, second difference. Right? Minus 3 minus 7 is a 4. 1 minus 3 is a 4. 5 minus 1 is a 4. 9 minus 5 is a 4. 8 minus 2 is a 6. 18 minus 8 is a 10. 32 minus 18 is 28. 14, right? 32 minus 18 is a 14. This is a 18. Now 10 minus 6 is a 4. 14 minus 10 is a 4. 18 minus 14 is a 4. So this is your first difference. This is your second difference. This is your first difference. So second difference would be 0. That is what is the rate of change of average rate of change. This is a linear function. This is a quadratic function. Any questions? Can I move on? Now, as I said, the graph can be like this or this for a quadratic function. So when the slope, when the rate of change, when the average rate of change is increasing, right? What did we say? It's concave up. This side, this would be concave, rate of change decreasing, right? Decreases, so that would be concave
Down.
down. Okay. Okay, one another observation in the same, I should not have erased it. Okay, 6, 10, 14, 18, sorry, 4, 4, 4. Okay, now we see clearly this is increasing. Is it concave up or this is the first difference, right? This is the second difference. First difference, which is the rate of change, average rate of change is increasing. Average rate of change is increasing. Second difference is positive, meaning rate of average rate of change is positive. Here it is concave up or concave down. Concave up or concave down?
Up.
Up. Okay. Whereas the major difference, I'll give you a summary. Okay, don't worry about it. You don't have to take notes now. I'll give you a summary, then you can take it. Now, the same thing in a quadratic function. If the first difference is decreasing, then the second difference will be what? The first difference goes on decreasing. What will be the second difference? Will be positive or negative?
Negative.
So it is going to go decreasing. Let's have some values. Okay, 18, 14, 10, 6. No, I don't want to go like that. Hold on. Let's go ahead with this. 50, 32, the reverse of that. 18, 8 and 2. if those are your y value. Let me write it down properly, guys. The y values are 50, 32, 18, 8, 2. First difference is what? 18, 14, 10, 6. What is the second difference? 4. Then what? Something feels so wrong to me. 4. 40, oh my god, 14 minus 18 is minus 4, 10 minus 14 is minus 4, 6 minus 10 is a minus 4. So do you see what is happening? The first difference is decreasing and the second difference is negative. Is it concave up or concave down?
Down.
Concave down. Am I making sense here, guys? Okay. Wait, I'm going to give you a summary that might help you better. This is what I want you to know. Make sense? Does that make sense? Can I move on? Okay. Shall I move on?
Yes.
Okay. Now, let's go ahead. I didn't even open anything else. We are just discussing linear quadratic as soon as we started. I don't even have anything to work with you. Hold on. Last class we did rates of change. We started, but we didn't do it properly, right? So let's go ahead. How about this? You're going to answer these questions now. You know about linear and quadratic function very well, okay? So let's go ahead and try these problems. What is the average rate of change for each function on the given interval? You are going to, what you can find out, what is the average rate of change for each of the function in the given interval? It's pretty easy to say. Tell me. It's not a hard one. You can just see and say. Yeah. You can just see and say. See the equation. You can say. I didn't see answers. I do see. That's correct. Akshada, first one na. Pranav, that's correct. Pranav. Navneet, first one is 5. Why do you think first one is 5, Navneet? Correct, Subhi. Sricharan, correct. Shrikar, correct. Ashrita, correct, ma. Navneet, why do you think
Oh,
the
that was
first
just
one?
a silly mistake.
Okay, I think it's 7, right, ma? They're just asking for the slope in different formats, that's all.
Yeah.
Yeah. Meaning they're just putting out different names and making it very confusing, that's all. How about this? Y equal to x square plus 4x minus 2. Do you want to try? Anya, I'm glad you are in, Anya. Abhiram, correct. Anya, did you get the answer? Yeah.
Yeah, it's
Yeah, I saw. Okay, how do you calculate the average rate of change? You can put, again, here guys, let me tell you. This, put it as, meaning, this is x1, x2. When you substitute these values, you will get y1, y2. So the average rate of change can be computed using, pretty easy, but we are just putting in different terms and making it very confusing. Y2 minus y1 by x2 minus x1, that's all. Same, but quadratic function. You have to evaluate it correctly. Can you try? Can we, can we try, guys? Oh my god. Can we try that? At least, yeah, 3 and 4 we can do. Only 2 problems, right? Do you get it, guys? Slowly only we are going up the intensity, I'm seeing. Akshada, is it? Which one is Akshada? Which one, ma? 3, 4, right? Both are minus 16?
My keyboard keeps auto correcting my numbers to 1.
Okay, I'll wait.
Yeah, no, I put my answer for number 3.
You put your answer for 3. Doesn't look correct. How did you do? Abhiram, the first one seems incorrect. Abhiram, the first one seems incorrect.
Yeah.
Yeah, second one seems okay. So be correct. Guys, if you keep quiet, you're not going to learn or you're going to forget. So let's be interactive, guys. Anya, did you get it, ma?
Yeah, I'm putting it in the chat.
Yeah. Just let me know, I can help. There's no need for you to definitely no. Yeah, Shrikar, that's right. Anybody who didn't understand? Okay, guys. So if you did not understand, right? I think there are a couple of you who did not understand. Okay, basically what I'm saying is, I will put x1 as minus 3. Okay, x2 as 2. Now, y will be equal to x square plus 4x minus 2. So, x equal to minus 3 I'll put first. Y will be equal to 9 minus 12 minus 2, right? 9 minus 14, which is a minus 5. X equal to 2. 4 plus 8 minus 2. 10. Right? What did I do? 4 plus 8. 4 plus 8 minus 2. 8, 9, 10, 11, 12, 12 minus 2 is a 10. Correct. Here, 3 3s are 9. Minus 12 minus 2 minus 14. Okay. What did you guys get? You're all getting a 3 and I'm getting something else. Okay, so I got 10 and what? Minus 5, right? Now this is y2, right? This is y1, right? We have x1, x2. Okay, if you name it properly, you will not go wrong. Okay, now y2 minus y1 is 10 minus minus 5 by 2 minus minus 3. So 15 by 5 is a 3. Any questions? That's the rate of change. Similarly, x1 is equal to 2, x2 is equal to 5, y1 will be equal to 2 to 4, 4 to 8 plus 4 plus 1, 13. y2 will be equal to, we're going to substitute a 5, so 50 plus 10 plus 1 is a 61. 61 minus 13 divided by 5 minus 2, that would be 8. 48 by 3, so that would be 16. Any questions? Any questions? That's it. Okay, now this one, let's see how it goes. Okay, now I'm going to give you for each of the problem that we are going to discuss, right? A quadratic function has the given rate of change. Let's see how we interpret this. Average rate of change is 1 on the interval. They've given one interval and they are saying for that interval, this is a quadratic function. Let me put it out, okay? It's a quadratic function. Average rate of change is 1 on the interval minus 3 less than or equal to x is less than or equal to 0. Average rate of change is 5 on the interval 0 less than x less than or equal to x is less than or equal to 3. They have given 3 intervals. Okay, let me construct that. Minus 3, 0 and then 0 to 3. They have given equal length intervals when you think of it, right? Average rate of change. We don't know the y values, but what they have given is average rate of change is 1 on this interval, and on this interval it is 5. Now what they are asking, what is the average rate of change of g on the interval 3 to 6? What do we do? We need to find out the average rate of change. We need to find out this value. How do we find it? Thoughts, guys? This is based out of what we studied, right? This is a quadratic function. So what is that we can do?
Would it be 9?
That's true. How did you find it? Good job.
Because before we saw that like it always increased by the same number.
Exactly, the second difference of a quadratic function is going to be the same. So we have this value. The second difference is positive and it's going to be increasing, right? That being the case, what should be this number if this 4 is going to be the same? Meaning the difference of this number, whatever question mark, minus 5 will be equal to 4. So question mark should be equal to a 9. Any questions, guys? Any questions? You got it?
Yes.
Everybody got it, huh? Okay. Meaning simple concepts, that's what I feel like. Okay, simple concept, but they put into different words, formats and make it a little bit hard. But let's see. How about this? Avni, is there anybody from East Coast in this group?
Yeah.
You're there, right,
I am.
Manya? Okay. Would it be okay for you to have a class 9 to 10?
Yeah, that's fine with me.
Oh, okay. Very sweet. Okay, we'll see, ma. After July 5th. Today it will be. Today, yeah, okay. We'll see, ma. Go ahead. No, no, okay. Yeah, for you it should be okay. We will continue. We'll make it earlier, right? 5:45. So I think I asked you wrongly. We'll do this problem. Average rate of change is -1. Please write it down in a different format, guys. This is so confusing to see. I will write 1, 5, 9, my x values. Then I will write my y values. What is my y value? I don't have my y value. But only thing I know is average rate of change is -1 on this interval. On this interval it's a -7. So what happens? Is it an increasing function or a decreasing? Is it increasing or decreasing? First difference.
Decrease.
Decreasing. Good. They're asking for 17 to 21. Oh my goodness. 17 to 21. What do we do? There's also a 13. What do we do? I'm going to wait. Oh, I see. Abhiram, thanks for the note. Avni, is that right?
I realized
Huh? You made a mistake, right?
yeah, I just subtracted.
Oh, okay. As long as you understand, it's fine. Akshada, where did you answer Akshada already?
That was an answer from an old question.
Okay. I think that's right. Ashita, I'm checking Ashita. I have the answer, so let me directly see. Yeah, that's correct. Oh, I know. Akshada, what was it? Yeah, Sricharan, correct. Akshada, correct, ma. So be correct. Shrikar, did you not take the test, Shrikar? In radians?
I don't think I did.
Okay, you're all looking at the homework? Navneet, that seems incorrect. Can you check, Navneet?
What?
Can you check?
The answer? I did not send my answer yet.
Oh, sorry, Madan. It was the previous problem. I think we should put question numbers, guys. I'm getting so confused.
Miss Priya, I edited my
Pranav, that's correct. Abhiram, did you get it?
Yeah, I'm typing it in.
Yeah. Just make sure you send an answer, because if you don't answer, you're not getting productivity out of the class. It's your class, so make use of it, is my request. Sahana, did you need help, ma? If you need help, just type it out, guys. I need help. Do it on the board. Simple.
I'm sending my answer.
Yeah, ma. Yeah, that's right, Abhiram. I think some are taking time. It's fine. Sahana. Okay, I'll wait, Sahana. Okay, I want to do more problems. Okay, with the question number, let me give you. How about this? Sahana, you can send the answer. I'll wait. Oh yeah, you sent it. Okay. 7th question. Let's do the 7th question. We'll have the question numbers, guys, so that I don't get confused and call you out. Average rate of change is 2 on the interval. Please take the radiance test, guys. Probably I'll give you another test after we finish 3 or 4 subtopics. Okay? Sorry guys, I was talking on mute. Okay. After this we are done. Okay. I did respond for everybody. That's right, Sri Charan. Ashrita correct. Shrikar correct. Should I wait for 7 and 8? If you're done, can I move on? Abhiram, I'm going to do it for you for sure. Okay, there is some mistake. I don't know what though. So average rate of change is 2 on the interval -1 to 1 and 3. Do you see? It's an equal length. It's equal length. We don't know the y values. These are the x values. But then the first difference is, they've cleanly given that the first difference between the two is 2. The second difference is 7. So what? I'm sorry. First difference on the first interval is 2. First difference in the second interval is 7. So second difference is 5. As a result, it should always be 5. But they're asking
Oh, yeah.
the interval. Did you get it?
Yes, ma'am. I got it.
Okay. Okay. So the answer should have been 3 and 10. You got it? Did you get it? Answer
Oh,
should have
yes,
been
ma'am.
-3 and 10. Can I move on? Abhiram, if you get it, I'll move on. Hence I'm asking. Did you get it?
Yes, ma'am, I did.
Okay. Let's go ahead. Okay. Okay. Now you are all analyzing only the context given. Okay. Given the equation, what is asked, check and find that out. It's just different words is what I'm saying. Overall, they are either asking for the first difference or the second difference. That's all. And now, given a context, you analyze, right? Now, you're given an equation. Are you given an equation? Yeah. You're given an equation, you analyzed. Next, you know what are you going to do? Given a table, you'll analyze the same thing. We'll see. I will try to complete one more topic for sure for today. At least 2 per day only it will work. Okay, last 2 weeks I was always doing one. We were doing it slowly. We'll never complete what we want to. Oh, is it? I'm checking. Please use question numbers, guys. Oh, that's nice, Pranav. Correct. Avni, have you given the answers for 9, 10, 11?
Yeah.
You read the question. I know what mistake you did. Did you read the question?
Yeah.
Yeah. So you just make sure whether they're asking the first difference or the second difference.
Oh, okay.
Yeah. See, that's what is confusing many a time. They are really asking for the second difference here. Oh wow, Shrikar, nice work. Akshada, the same mistake just like Avni's. They're asking for the second difference, ma. Did you get it?
Yeah, I'll change it.
Yeah. Uh, that's right, Pranav. Everything is right. Oh wow, Sahana. Are you finding this easy, Sahana? Compared to the previous one? Yes, right?
Not easy, but I'm able to do it.
Oh, nice. Abhiram, everything is correct. Ashrita, this 10 and 11 are incorrect, ma, Ashrita.
Check again.
Yeah, I can also do it on the board. You want me to directly do it on the board? That's fine too. So, okay, let's go ahead and try. Let me pick out. Then only it's easy for me to find the second difference, right? So minus 1 means 1 minus 3 plus 8. 9 minus 3 is a 6. 0 is a 8. 1 is 1 plus 3 plus 8. 12. Second one is 4 plus 6 plus 8. 18. Now the first difference is 2. 8 minus 6. 12 minus 8 is 4. This is 6. This is 2. This is 2. So when you look at it, right, this is clearly increasing. Second difference is positive. So I can say this function is concave up. You got it?
Yeah.
So here f of x. If you can do the same thing here, I'm fine. If you understood the concept, we'll move on.
I
Can we move-
just miscalculated both of them, I think, because
Okay.
I did it the same way. I think I just probably just added or subtracted wrong somewhere.
Okay, so you, as long as you get the concept, we'll move on, I feel. Okay, so equations is done. What else we need to do? I said we need to do tables. Okay, at least 2 we need to do with tables and then test prep. Oh my god. Let's see. Yeah, we'll do tables. Let's see. I'll make it bigger table for you. Okay. I will just write out the question. You do. If there is anything incorrect, then I'll intervene. How about this? Guys, if you find it tough, please call out. It's your class. Make use of it. That's my request. Again. Let me see. I don't know have the answer. So great. Absolutely, I will do on the board.
Also, I just
This is correct. Soluma?
I just closed the tab and I don't want to open it again.
Shrikar, that's right. I'll do it on the board. There are a couple of requests to do on the board, so I will. Yep, that's right. So basically, when you're given a table, what decides concave up, concave down? So first difference and second difference can decide. You don't even have to go to second difference, okay? First difference, if it is first difference y value, let's say some y value, first difference is increasing, second difference will be positive naturally, then it is concave up. 1 second guys, if it is decreasing, it's negative, then it is concave down. This is the main rule. Sorry guys, so here let's go ahead. First difference is 11 minus 10 1, 14 minus 13 is 3, 20 minus 14, 29 minus 29. If you want, I'll calculate the second difference as well. What are you getting? 2, something feels wrong. 1, equal length intervals, 1, 3, then what did I do? 6, 9. Was there a mistake? Okay, so basically this is okay still. See, this is increasing, right? So it is concave up. First difference is minus 25. Second difference 40, 50, 60, 70, 75, right? 40 minus 75 is minus 35. 0 minus 40 is minus 40. See, the negative values go on increasing. That means it's becoming negative. It's decreasing. Minus 50, minus 0. So minus 50. Now see here what happens. Minus 35, minus 25. Minus 10, minus 10, minus 10. So second difference is negative. First difference is decreasing. Decreasing, negative. This is increasing, positive. So this is concave up, This is concave down. Any questions? Did you guys get it? Okay, let's move on. Okay, now let's go to some test prep pieces. The sense. Okay, how about this? See whether you can get this. It's a nice one. I'm going to increase the size. 1 second. Okay, how about this? Shall we do this? The table gives values of the function h for selected values of. See, it's a teeny tiny bit you have to think, but it is all based on concepts that we discussed. This is like an MCQ, meaning I don't know whether you guys are aware of the AP pre-calc is the first AP exam you're all taking, right? Considering that, you will have an MCQ section and a free response section. Free response is where you're going to write out detailed answers. MCQ is the section is a multiple choice section. Usually you're allowed to use the calculator for a that I'll verify and tell you all guys, I forgot, but then for some you can use calculators, for some you cannot use calculators. If you get, I think, 80% or so, then you're given a 5 on any AP exam. Are you all aware of that or no? Guys, I need to know, are you aware of it or no?
No.
Okay, then I'll do one thing. Next week I'll put it up. I'll go verify properly and put it out. What if you get, what will happen? All those details I'll tell you. Okay, I clearly don't remember. Okay, so many times I've seen, but then MCQ and FRQ, I think there are 6 FRQs, 4 or 6, I don't remember really. FRQs you need to answer, and then I think it's I don't know, 30 or 50. I don't remember really that many MCQs. MCQs is all multiple choice questions. FRQs is all they'll give. Free response means you will be able to answer and they'll be able to score the detailed answers for you. Okay, but in an AP exam it's very easy to make a 5 provided you get most of the concepts right, most of the concepts very nicely thoroughly done during the year. Okay, for that matter, I don't want you to miss any FRQ, but for your information, even if you miss one full FRQ, you're not going to attempt it, and you get everything else right, you get a 5. But please don't rely on that. Okay, just get to know everything so that you are on the safer end. I think it's an 80% if you get a 5. Yeah, I'm checking. Now do this problem. We'll revise. The third problem is very difficult. Let me see, guys. Let's see how we do. Wow, Subi, good job, Subi. Navneet, nice. Pranav, nice. If you're stuck, that also put it out. We'll do it together. That's right, Mashrita. You can start doing the second problem too, whoever is done. That's right, Sahana. Shrikar, did you do the fourth problem? Sricharan, that seems right. One of you want to explain how you did that, because there are people who didn't get the answers.
Wait, Miss Priya, I have all the answers. Like, I did them all, and then I'm just submitting one thing. Does that work too? Because I'm putting it in the chat now.
Okay. Then I'll wait. Avni correct, Abhiram correct. I think everybody got it. Shrikar, did you get it?
Did I send my answer?
No. Did you get it?
I think I got it.
Okay, then send. Even if you didn't get, does not matter, just send. Yeah, that's right. Anya, you got it, right, Ma?
Yeah, I'm sending.
Oh, Pranav, no. Oh, 11 is the answer for the next one, huh? Oh my goodness. Not really, Pranav. The choices are these. Choices do not have the 11 in it. See, here it's a quadratic function. You need to be finding the second difference. Can I help?
Are those two right?
Checking, ma'am.
Miss Priya, can you show the answers for
Yeah,
sister?
ma. Yeah. Oh, wow, Anya, you got both, I think, right. Let me see for the second one, Anya. Yeah, Anya, both are right. Sri Charan, correct. 15th. Navneet, not really. Why? Okay, let's do it on the board. So first difference, I always go successive term minus the previous term. So minus 1 plus 5 is a 4. Then 0 minus 1. So that's a 1. Now my only problem, I do understand that my second difference is going to be minus 3. Right? If it is a minus 3, what would happen to the next number? It has to be a minus 3. So how do I do it? So this is going to be a minus 3. So add them together. Is it going to be a minus 2? Yep. It's going to be a minus 2. So like that, did you move on? Now again, here you're going to add these two, right? So this is going to be, let's see, 5, 6, 7, 8. You have to go the reverse path. That's it. Minus 2, minus 3. Now you added these together. Similarly, you'll go ahead and add these two, right? Yeah, you got a minus 2. Now, what should be this value? You keep on adding, right? So you added this. Now you will add these two. You'll get a 2. After that, what do you do? Again, 2. Again, the second difference has to be minus 3, right? If it is a minus 3, I'll add them together. It will be a minus 5. If it's a minus 5, it will be a... Something is wrong to me.
You have to go in intervals of 2.
1 second. Did I make a mistake? Hold on.
We went like 5, 6, 7, but it was like 2 to 4.
Oh, sorry. Yes. Sorry, guys. I did not see. 6 and 8, right now? 6 and 8. So here, what mistake did I do? Let's see. 6 and 8. Till this, did I have it correct? I don't know. Yeah. What did I get? Minus 2. Did I get a minus 2? Yeah. Minus 2. Minus 3 is correct. Minus 2 is correct. And then 6 and 8, right? What they're asking for G of 8. Okay, then we need to continue. That minus 2 is incorrect. See, when you're adding together, right? This is a minus 2. I wrote a plus 2 here by mistake. Minus 2. Now what happens? Again, I know the second difference is minus 3. When it is minus 3, I have to first write the first difference. It will be minus 5. I add them together. Minus 5, minus 2, minus 5 is minus 7. So minus 7 should be your answer. Am I clear?
Yeah.
Okay. Now the last problem is a little harder. Let's see. We'll do it together. It's the last of the lot, but we'll move on to the next one after that. You lose. Function p is given by p of x equal to g of x plus 1 minus g of x. There is some function p of x, okay? That is written in terms of another function. If p of x equal to 2, they have given p of x as constant. Which of the following statements are true? They have said the graph of g has a positive slope. The graph g is concave up. G is increasing. How do you determine all this? Any thoughts? If you can do it by yourself, try. If you can't, then I'll do it with you. Let me stop share. Why I'm not able to see any of you? 1 second. That's so much better. Go ahead. Shall I do or you want to try? How am I going to find out? See, what I need to conclude is graph G, is it concave up or down? Graph G is a positive slope. G is increasing. How to find that out? What shall we do? What will give that? Should I wait or can I go ahead and solve? Please let me know, guys. If you're shy, then please send in chat at least, so I'll know what should I do. Any thoughts? Oh wow, is it? I don't know the answer honestly. I need to verify the answer. Otherwise, I'll work it out on the board. Not really, Ashrita. Let's try. Okay. What will answer the graph G has positive slope? What can determine that? I am given p of x equal to g of x plus 1 minus g of x. And they have given p of x equal to 2. If I want to know whether the graph of G is a positive slope, is concave up, what is going to help me decide that? The only value that can, one of the main values that can help me decide that is the first difference. What is the first difference? Basically the slope. How to find the slope? Slope is the first difference, right? What is the first difference? For let's say the points are x and x plus 1. There are 2 points x and x plus 1. So what will I write? I will write p of x is g of x plus 1. So what will I write if I want the slope of g of x? G of x plus 1 minus g of x divided by x plus 1 minus x. That is your first difference. What is the first difference? What is this? That is equal to p of x. So the first difference is itself 2. First difference is itself 2. That is your first difference for the function, right? For the g of x function, the slope is 2. So what can you tell about it? What type of a function is g of x?
Linear.
Linear, good job. So that tells me what and all you can strike off here easily. Yeah, p is positive and g is increasing. See, everything is p positive. Tell me about g. G is increasing. It's a linear function, right? And has a positive slope. Now, because it has a positive slope, do you see? So the third one is definitely right. The third one is definitely right. The graph G is concave up. Concave up and down doesn't even come in a linear function. The graph of G always has a positive slope. Yes, right? The slope is always 2. That means this is as well correct. So the answer is D. Does that make sense, Rishti? Your class has not started. Does that make sense?
Yeah.
You can
Yeah, I
Guys,
watched the recording, so I like understand it.
oh no, this is the pre-cal class I'm saying.
Oh,
Okay, your class, yeah. Few more minutes. Any questions, guys? Any questions?
No.
Okay. Now,
No.
you want to conclude now, or I can go on? Hold on. What is the next? I'll tell you for the next week, right? Okay. For the next week, we'll cover polynomial functions and rates of change. What did we do? We did linear functions, we did quadratic functions, we talked about first difference, second difference. Because of that first difference, second difference, we gave new terms to it. Average rate of change, rate of average rate of change, slope, first difference, second difference, so many things we did. And after that, we also discussed concave up, concave down. So for this, all for linear and quadratic functions we did, right? So like that, next week we'll discuss polynomial functions and rates of change. Okay, in that I'm assuming if you can be, meaning if you can go over some polynomial functions, how to find the leading coefficient, whether there can be a zero or not between an interval, minimum, maximum, given a quadratic, given a polynomial function, you have to be able to say whether it has a minimum or a maximum, all these things, relative maximum, absolute maximum, given a graph, all that we'll discuss. And we'll also discuss the usage of calculators. So, meaning why to graph a function, to graph how to graph a polynomial function using a calculator. I think you guys know, but please bring the calculator, because there will be a couple of calculator active problems we'll be doing as a part of next week in polynomial functions and rates of change. Any questions? Any questions? So polynomial functions, rates of change, complex zeros we will do, and even and odd polynomials is also something we will try to do. Any questions? Can I stop here? Yeah, I will. Overall, I don't know, guys. Overall, I'm thinking we should finish. If we finish 1.5 units, we'll be better off. Yeah, if we finish 1.5 units, we'll be better off. But I don't know. Let's see. At least we finish one unit, it's 14 subtopics. I don't know. I don't think we'll get done before summer. Maybe we'll see. Yeah. Any questions? Okay, guys, then I'll stop you here. We'll do it next week. Please do the homework, or at least go over the homework. Make sure you know all the problems. If not, bring the problems to class to solve. Okay, bye. Have a nice week ahead. Enjoy the summer as well.
Bye.
bye, Miss
Bye,
Priya.
That was
Priya.
pretty good.
Thank you.
Thank you.
Bye, guys. Hi,
Miss
Anya.
Yeah, Miss Priya, I'd sent an email asking to retake the assessment because I don't know what happened, but it said all my answers had turned to D. I don't know why.
Okay, no problem. Can you use another email ID?
Oh yeah, sure. Here, I can put it in the chat if that helps.
It doesn't. No. You can take it by yourself. Same link with a different email ID.
Okay. Yeah.
That's
Thank
the
you, Miss
secret.
Priya.
You got it?
Okay.
Yeah. Hey, Anya, I wanted to ask you, whatever we are discussing in class, do you get to use it in school?
We already did some of this stuff before Algebra 2 ended.
Before Algebra 2 ended. So what were you doing in class?
Everything we've done so far I've already covered. We ended on like I think it was like I'm trying to remember. It was like I have a notebook right here.
And are you taking AP Pre-Calc, ma?
Yeah.
Oh, then we should. Okay. See, the thing is, everything would or already everything what we have discussed in Unit 1 and 2 is already covered almost in Algebra 2 itself.
Yeah.
But yeah, it's a lot of grinding. That's all on the same topics, but different ways of doing it. That's all. Only when we go to polar graphs, which is in Unit 3, it's completely new in AP Pre-Calc.
Okay, yeah.
And unfortunately, you know what? AP Pre-Calc we need to cover just 3 or 4 units. Those are the only things that are useful for AP Pre-Calc exam. The problem is, once we finish the 3rd unit, the 4th unit, parametrics, vectors, matrices and all is not even covered as a part of your AP Pre-Calc exam. So we'll do what best we can. We'll practice extra, but only 3 units are required.
Okay, yeah.
Make sense? Yeah.
Yeah, thank you, Miss Priya. Bye.
Bye. Hi guys, how are you all? Oh, Johan, I'm so impressed. As soon as you go, you take a class, I'm impressed. He just landed in India and he's in for the class. Funny, right? It's really funny. Yeah, usually I ask my kids to do as well, but amazing. Meaning you should have so many factors should pitch in, right? You should have internet connectivity, so many things. Going to a house, I don't know. Yeah, it's hard for everything to fall in place, but glad you're in. Okay, so let's go ahead. Vibha is not in here. Vibha is another person for whom we had this class. Okay, before I start moving, guys, Vibha is totally in India. Okay, Johan at least will come back from India. So after July 15th, right? How good are you all? Meaning, I really want to have the class from 7 to 8. That is all there. But are you also flexible to have the class from 7:30 to 8:30 CT? Meaning, do you have anything conflicting on Friday evenings? Srishti, do you know? Please tell me, guys. Yes, no.
Yeah, like, is it okay if it can be like a little bit later? Like, this time is like good.
This time, my only problem is when the class gets over, it's 10:15
Oh, okay.
for me.
Yeah.
So at least by 15 minutes, I want to move it in.
Yeah.
Is that okay?
Yeah, that's
15-20 minutes at least I want to move. If it is 7:30 to 8:30, it's hard for you, huh?
No, that's good. Yeah, that's good.
How about you, Lasya?
7:30 to 8:30 is fine.
How about you, Avyuk and Shreya?
That's fine.
How about you, Shreya?
Like anytime after 7.
Thank you, guys. Okay, I don't think we should waste more time. Let's move on. Okay, parent functions, it's great. Okay, Avyuk, did you see the comment I have given you?
Yeah, I saw.
Okay, I'm so sorry if I was not clear.
No, it's fine.
Okay, but then you can practice the parent functions.
Yeah, I will do it again.
Yeah, but I'm so impressed that you did from the book. Okay, so we'll move on. Srishti, you were able to see through the recording. Shreya, did you find the homework okay?
I did the first homework one, and then I got started on the second and third, but I didn't finish completely.
Okay, no problem. Shreya, was it okay with you? Hey, last year, did you get to do the homework, ma?
I did. I need to work on the second one though. I haven't seen that you edited it until like yesterday, and I
Oh, okay. Somebody asked, then only I saw.
yeah, I'll finish it and turn it into you by tomorrow, maybe.
Okay. And who else is there in this group? Navni? Yeah. Okay. Okay, let's go ahead. For you guys, what did I have? I wanted to cover, yeah, I know what I want to cover. Let me not go to the book yet. Okay, let's do this. Okay, having discussed the properties of functions, right? Basic functions you already did. What functions did you do? You might have done linear, quadratic, cube root, square root, absolute value. Have you done all of these? Right, okay. And one another function that you can know is this one. This is little new to you guys. Let me go over the order itself. I don't want to misguide you. Hold on. I'm going to look through the order what we have in the classroom in that document. And add 2 more pieces to what you already did. You did till 22. Okay. Did you do cube root? Did you guys do cube root? 22. You didn't do cube root. No, you didn't do cube root. That's okay. That's okay. Let's see. How about this? I said I'll do transformations, right? How about this? You know what this function is called? Okay, let's do the table because this is completely new to you. It should go into your brain, right? -3, -2, minus q. No, this won't work. -27, -9, minus. It's so hard. How about this? We'll have this table, so will be equal to cube root of x, right? So it's a -3, -2, -1, 0, 1, 2, 3. So how do we plot it? 0, 0 is done. -1, 1. Oh my god, what did I do? 0, 0, -1, 1, then -2, -8. Okay, -8 is -2. Does it make sense, guys? 8 is 2, 1, 1. So we plotted only these. Make sense? This is how you get the graph. Now, would you be able to, if I directly give it to you for homework, would you be able to take it forward or should we do in class? I am okay with either, but please feel free to say. Should I go over these or can you do it as homework?
You don't need to go over.
Okay, thanks. Even if one of you say, I'll take it. So cube root function, you'll do it at home this week. Is there anything? This is one thing. Yeah, this is what I wanted to discuss with you guys. This function we'll do. Okay, these two functions we'll do. Okay, the logarithmic function you don't need now, but these two functions we'll do. You will find it very useful if we do. Okay, so here we go. Name. You know what is this function? Let me show you the table. It's interesting. I'll just do 3 reference points, okay? These are the reference points for this function. Reference points means the famous 3 points that will always be used in transformations. Not 0, 0. 1 minute. 0 is undefined. Okay. No, for -2 it's a 0.5 and 2 it's a 0.5. Let's see. See, 2 it's a 0.5 and then you have 1, 1, -1, 1, and then you have 1, 1. Oh yeah, we did. And then -2 is a -0.5. Okay, 4 points we plotted, right? And then 0 is undefined. See, at 0, this is not a continuous function and it is continuous only on this domain and this domain. But there is a discontinuity here. You see what happens here? It goes to infinity. Because why? This is 1 by x function. This is called a rational odd function. Rational odd function. How about y equal to 1 by x square? Rational even function. Okay. Now, what is the symmetry here? Is it even or odd or what?
It's odd.
Odd. Why? How it is determined?
Because like, isn't it about the origin?
Yeah, it's symmetric about the origin. See,
Yeah.
when you pull the origin, when you hold the origin and then you flip it, it'll flip. You see, it'll flip and fall on the same. So it's odd. Symmetry is around origin. Name is rational odd. Now, what happens at y at 0, right? 1 by 0. Whenever you have a division by 0, right? Whenever you have a division by 0, the operation is undefined. Yeah. Today I have a request, guys. I will finish the class sharp at 10:15. I have to go out for a pickup. Okay, 10:15 means my time 10:15, your time 9:15. Okay. Just for today. Okay, if you have clarifications after the class, we'll discuss next week or in the meantime whenever you want. Okay. During the week as well we can do if you have clarifications that are to be solved after the class. Okay. Equation is 1 by x. What is the domain? How do we write the domain for this function? It's hard, right? What is the domain of this function? How do you it's a little different because it's the first time you're doing it, I think.
It's in algebra 1, I think, right?
Oh, it was? Okay. What was the domain?
Negative infinity.
Infinity to?
Yeah. 0. And then 0 and then infinity.
Okay, and then in between what do you do?
Undefined, right?
Good. This is correct actually. Go ahead.
Would it be a union?
Union. Good job. Union means, first of all, this parenthesis tells you that 0 is not included. Okay? And this domain, 0 is not included. Union means you have to take into account this as well as this. I'll tell you what is the meaning of union. Suppose let's say A is a set of numbers, group of numbers, 1, 2, 5, 7. B is another set of numbers. Okay, C is another set of numbers. You know what is A union B? No, wait. Okay, 10, 7. What is A union B? 1, 2, 5, 7. You have to take both. What is A union C? 1, 2, 5, 7, 10. What is A intersection B? What is it? Intersection means 2, 5. What is A intersection C? 7. What is B intersection C? Empty set. Make sense, guys? Unfortunately, we don't cover all this. I don't know why. That's how the curriculum is, okay? In India, they learn very early. Can I move on? Okay, now let's go ahead. Oh, if I delete everything will go. Oh my gosh. Okay, 1 by x, name is rational odd. Domain is 0 to domain is minus infinity to 0, 0 to infinity, union. Range is what? Who can tell me the range?
Isn't it just the same?
Yeah, always lowest point, then you have to go up. Okay, symmetry is we did discuss this, right? Origin, order, interval of increasing is what? What is the interval of? Is it increasing any time?
Nothing.
Is it increasing?
No, it's not.
Yeah, is it decreasing?
No.
It is, right? See?
Yeah.
Goes on decreasing. Again, it comes from infinity and then goes on decreasing. So I would say minus infinity to 0, 0 to
Infinity.
infinity. Remember, increasing decreasing interval should always be written by parenthesis only, no square brackets or curly braces you're going to use for intervals of increasing decreasing. Zeros, none, right? It is not cutting the y-axis at all. At the what is this line called?
Asymptote.
Asymptote. Good job. Okay, in algebra 1, for an exponential growth function, we had a curve like this. Okay, for an exponential decay function, it didn't go up, it goes and tries to merge with the x-axis. So for an exponential decay function, what did we do? It's about to go merge with the x-axis, so y equal to 0. This line was your asymptote. That is the line to which any graph is going to coincide, right? Now, that's called the asymptote. So here, again, our graph, right, tries to go ahead and merge with this. What is this line's equation called? What is this line's equation called? What is the equation of x-axis? I told you. What is the equation of x-axis? Y equal to 0. What is the equation of the vertical line called?
X equals to
X
0.
equals
X
0.
equal to 0. So, one difference between the two I'll tell you. Here you have a sleeping asymptote, horizontal asymptote. Here you have a vertical asymptote. Any questions? Good. Now, x-intercepts, is it cutting the x-axis? None. Asymptotes, yes. X equal to 0. End behavior, as x tends to minus infinity, y tends to what, guys? Shreya, you help me. As x tends to minus infinity, y tends to
0.
0. As x tends to infinity, y tends to
0.
0. Correct. Can I move on? So that's it. Okay. I really wanted to go to transformation, but I don't know. Okay. This is your 1 by x square. Can I let you do it at home? Why should we do again and again? Can you do this at home for this one? This is y equal to 1 by x squared.
Yeah.
Okay, we'll not discuss this and take away class time. Can I move on?
Yeah.
If you don't understand any piece, come back and ask. Okay, now I want to do first I thought of doing, actually I had planned for inverses and compositions of generally of functions, okay, but I think I don't know. Yeah, we'll do some transformations. I feel I don't think inverses and compositions can wait. One second. Let's do this. Oh. Move the monster, yes. Oh, okay. How about this? We'll do this, huh? Yeah, I think we'll do this. Let's try to understand from this. This is where I wanted to start with, and then we'll move on with more complex ones. Yeah, I would like to do this one. I want the entire thing. Hold on, guys. What happened to... Okay, let's do this first one. I don't want to do h of x plus 2. Okay, this is h of x. I'm going to paste it in your board, okay? How about this? Think about it for a while. A graph is given. the graph, we don't know, some function graph is given. Okay, now why is it so, 1 second guys, I'm trying to bring it to the middle. Oh, that's good. Okay, a graph is given. I call the function as h of x. Okay, now 1 second. Okay, that's better. Okay, now using this table, we are going to use the table, we are going to use the graph, we'll complete some transformations. Okay, for the first function, what are we going to do? Let's see. For this function, first let me fill in the values. For -3, this you know, -1, it's going to be -1, -2, -3. 0 is going to be 1, 1 is going to be 0, 2 is going to be 1, 3 is going to be 0. Any questions still here? I just put down the xy coordinates for the function, that's all I did. Okay, but we are going to look at transformation in so much detail. Okay, this is the crux of algebra 2. Okay, once we understand transformations, every function will become very easy as we move up. Now, using the above table and graph, complete the following transformation by graphing the transformed function. Graphing a transform function, basically you know about all our many of our parent functions now. You know linear, you know quadratic, you know cubic, cube root, square, square root, absolute value, so many parent functions you know. Okay, but going further, you're going to be given equations like this and you'll be asked, hey, write down the process and graph the transformed function. When I transform this function, how does it look like? So here, what have they done? H of x plus 2. This is h of x. Okay, h of x plus 2. By adding the 2, what are they doing in that h of x plus 2? Let's see. How about this? Here, the plus 2. 2 is getting added to the y value of the graph. Any question? 2 is getting added to the y value of the graph. Makes sense, guys? So, from the parent function, what are we going to do? We have x value, we have y value. X value remains the same. There is no change in our x value, correct? But y value, what is the process we are going to do? The original y plus 2 is our y here. Okay, so this is going to be 2, this is going to be a -1, this is going to be a 3. Okay, before I do that, right, why should I do that? Let me do it slowly so that everybody gets it at one shot. 1 plus 2, 0 plus 2, 1 plus 2, 0 plus 2. Now 2 minus 1, 3, 2, 3, 2. Any questions? Okay, now shall we graph it? Once I graph it, you will understand how to write the verbal description of the transformation. So let's go ahead. What am I going to graph? My current function g of x I am going to graph here. So I will plot -3, 1, 2, 3, -3 and a 2. I'll be slow. And then -1 and a -1. And then 0 and a 3. Why am I getting like that? Something I feel is wrong. That's right actually. Okay, and then 1 and a 2. What did I do? 1 and a 2, and then 2 and a 3, 2, 3, and then 3 and a 2. So basically the function is like this goes up, comes down, and then a semicircle. Make sense, guys? So what happened to our original function? Original function was the same, but what happened to it? Basically this arch, right? This arch is here. So what happened to our original function? Arch was here, right? So what is the change here? The starting point was here, right? What happened to our starting point?
Ma'am, for the y value, x value minus 1, it was supposed to be y minus 1. You put y as 1.
Okay. No, I'll take it. Minus 3 minus 1. Okay. Go again, Jaya. What was that?
For that value, when you put minus 3 plus 2, you put minus 1, but on the graph, you drew 1.
That's the deal. That's why it looks different, right? Thank you. Let's do it. Okay. So, minus 3, 2. 1, 2, 3. Minus 3, 2. I really appreciate if you're picking on this. It's easier for me to quickly fix. Minus 1, minus 1. That's right, right?
The minus 3, now you did the x minus 3 around. It's on the minus 2 one.
Minus 3 is a 2. That's correct, right? And then minus 1 is a minus 1. Okay, 0 is a 3. Oh, 0 is a 3. 1, 2, 3. Is this right, Jaya, now?
Ma'am, you drew the first dot on minus 2.
Oh, okay. I think I'm blind. Minus 3 is at a 2. Minus 1 is at a minus 1. 0 is at a 1, 2, 3. And then 1, 2, 3. Okay. Does that make sense? Jaya, is that right?
Yes, ma'am.
1 is a 2. Okay. And then 2 is a 3. 1, 2, 3. This is like a circle. See what happens. The same graph, when you look at it, it's the same graph, but then see, the same triangle comes up. The same triangle comes here, okay? But then what happens to each point? Did you see this point? What happened? What is the change? Every point, check what happened to every point. The point that was at 0 went here. And then the point that was at 1, right? The point that was at 1 went up here. The point here, the semicircle upper part, was where at 1, right? The semicircle part, upper part was at 1, it went up. So what is the change here? How can I verbally describe this change? Move up by 2 units. Can I say that? Does that make sense? So the graph moved up by 2 units. Every point was shifted 2 units up. This point was shifted 2 units up. This point was shifted 2 units up. This point was shifted 2 units up. Any questions? Okay. Now, what is the domain and range? Can you tell me the domain and range now? You can see it on the table itself and tell. What is the domain and range?
The domain is -3, -1.
-3 to? -3 to 3, right?
Yeah.
Yeah, -3 is included, 3 is included. Range is? What is the minimum point? What is the maximum point? That's all.
-1 to 3.
Make sense? Are we clear, guys? We are clear, right? Okay. Now how about this? I'm going to ask you to graph this. Why there is a shade on that graph? I don't get it. Oh, this is better. Okay. Now how about this? Number 2, we are going to do t of x equal to h of x minus 2. So what will we do? What will the graph be? Shall we? Okay, we'll do that. Let's do that. I'm going to do minus 2 now. Okay, t of x will be minus 2. So what do you think will happen to each of the points? What do you think will happen to each of the points? Hmm?
They'll all go down by 2.
Yes, they will all go down by 2. They'll all go down by 2. So the process is minus 3. They'll all go down by 2, but you have to minus the y values, right? 0 minus 2, minus 3 minus 2, 1 minus 2, 0 minus 2, 1 minus 0, 0 minus 2. Did I do it correctly? Yes, I did it.
Ma'am, for the 2 one, you did 1 minus 0 instead of 1 minus 2.
For the
X value 2 in the table GX.
Lila, did I do this correctly first? Minus 3. See, again and again, I should not have erased it. Minus 3, 0, minus 1 is a minus 3, 0 is a 1. Then 1 is a 0, 2 is a 1, 3 is a 0. That's right. So here, 0 minus 2, minus 3, minus 2, 1 minus 2, 0 minus 2. Oh my gosh. Okay. So here, correct, Jaya?
Yes, ma'am.
Okay. Minus 2. Does it make sense? So I'm going to do minus 3 minus 2, minus 3 minus 2, and then minus 1 is going to be minus 1 is going to be 1, 2, 3, 4, 5. Oh my god. 0 is a minus 1, and then 1 is a minus 2. 1 is a minus 2. Then 2 is a minus 1. So what happens here? Let's do it. It's going to go like this, go up, come down, and then the semicircle. Does that make sense, guys? So what happened to the entire graph? Check what happened to the function. It was here, it moved here. This was where? It was at a minus 3. It was here. Let me put it in a different color. This was here, it moved down. This was here, again it moved down. This point was here, you see? It was here, it moved down. Again, the semicircle top part was at 1, it moved here. Again, this was on the x-axis, it moved down. So, verbal description, how can I describe that? The graph moved down by 2 units. What will be the domain and range? The domain remains the same, but the range, the lowest value first, and then the highest value next. Any questions? Any questions? Can I move on? Okay, cool. How about this? Okay. How about this? I'm going to, let's see. How about this? Let's do it in this pencil. I'm going to take g of x. This time, you know what I'm going to take? H of x minus 2. What happens? What do you think happens? What do you think will happen? Any thoughts? We have studied this in Algebra 1. What will happen to the graph?
Right too.
Yes, it'll move right too. Good job. Do you remember? That's nice, Lasya. Let's see. Okay, one more time, guys. I'm sorry. 0. And then this one is minus 3, 1, 0 and 0. This one is 1. Okay. Now let's try to plot. The process is, okay. X, you see X value, right? X value moves right by 2. See, we are touching the x-axis this time. If this is the graph h of x, see, it's always like this is x minus 2. That means it is moving to the right by 2 units. In the sense, x will be incremented by 2. For the transformed graph, x would be incremented by 2. How are we going to do? Let's see. Y is going to remain the same. 0 minus 3. See, I'm copying this. 0 minus 3, 1, 0, 1, 0. No change on the y value this time. But whatever is inside the parenthesis is a change in x. X is a little tricky. The minus will move the graph to the right. How am I saying this? Why do I say this? Let's see. See, I'm going to show before we go into this why that minus 2 should be to the right and not left is what I'm going to show you. Okay, you have a line. Okay, 1 comma 1, 2 comma 2, 3 comma 3, 0 comma 0, minus 1 comma minus 1. Okay, these are the points, right? Minus 1. Okay, these are the points. Now the graph, let's say, moves to the right. What happens? The graph moves to the right. So this point, let's say, moves to the right by 2. I want to show you, okay, this again 2, this again 2, this again 2, this again 2. This is what we studied in algebra 1, if you remember. So the previous graph moved to the right by 2, moved to the right by 2. That means since it was a line, I can as well say, how can I say it also moved down by 2? Any questions? Suppose if I move the same graph to the left, what would happen? Here I moved the same graph to the left by 2. X point I'm changing. You see, if you change the x point, right? Now what does that mean? It went up by 2 or it went to the left by 2. Any questions, guys? Any questions? Okay, so now the here this, what did we discuss? Okay, the process is x values change. Whatever is inside the parenthesis, a change in x. X is always tricky and notorious. Okay, plus 2 means we'll think it's moving to the right, but there's a minus 2, right? So what do we do? For the x value, what would you do? If you want to move to the, what did we say? We are moving to the right. So minus 3, what is the process then? Minus 3, what's the process here? I should not be using this table, right? Wait, guys, I cannot use this table because transform value, give me a minute, I will use another graph. You will not understand anything if I do it in this. Let's see, I want an empty graph. Okay, so I need this empty graph. So I had the empty graph here. 1 second, guys. Okay, but I want it very big. Okay, let's use this graph. Yeah, I think this is better. How about this? Let me use this. Domain range, verbal description will do. Now, oh, so sad. Okay, let me erase, not to confuse you. I don't want this. Okay, hold on. Let's put it nicely, then do one by one. Okay, so this is my transform graph. This is my original graph. Okay, now let's see. This is even smaller. That's not okay, guys. Give me a minute, guys. I want it to be bigger. Okay. H of x is given. Are you all able to see? Are you all able to see, guys? You have to tell me, guys. I'm asking. Is this enough of zooming? Are you all able to see?
Yeah.
Okay, thanks. You know what? At office, I used to be a person like you. I'll not just like that answer when somebody asks something. So after I started teaching, I understood the pain of not getting answers. So I started answering at office. If somebody asks a question, nobody in the team will answer. That's what happens. So I also learned that way. So let's see. How about this? Minus 3, let's see. 0, minus 1 is a minus 3, 0 is a 1, 1 is a 0, 0, 1. Okay, now we want g of x will be equal to, what did we say, h of x minus 2 we said, right? X value should be incremented by 2. So x value is minus 3 plus 2, minus 1 plus 2, 0 plus 2, 1 plus 2, 2 plus 2, 3 plus 2. That will be minus 1, 1, 2, 3, 4, 5. So it will be minus 1 comma 0, minus 1, minus 1, minus 1 comma 0, correct. Then 1 comma minus 3, 1 comma 3, my eyes. Okay, let me put it at least in red. 2 comma 1, 3 comma 0, 3 comma 0, 4 comma 1, 4 comma 1, then 5 comma 0. So basically it goes like this, then goes like this, then the triangle goes, and then a circle. Same thing, but what happened to the graph? This point we got started, it moved like this. Then this point moved like this to here. You see? Then this point would have moved like this. You see? It came here. So this is, what is the verbal description I'll say? Graph moved to the right by 2. In the parenthesis, when you see a minus 2. So what would happen to this graph if I say h of x plus 2? What would that graph be? Which coordinate will change first of all? Here, which coordinate should I change to write my transformed table? Which coordinate should I change, guys? Okay. The x value will change by how? This is actually x minus minus 2. So the format is just x minus h, guys. H is the units, how much you horizontally translate. Okay, horizontally, h is the unit you horizontally translate. The formula, meaning the way you see the left and right movement is, the format, the general format has x minus h. So when h is positive, then you go right. When h is negative, you go left. That's all it is. That is why here think of it as x minus the number of units. Okay, this minus is always in the general format of transformation. Okay, so 2 is basically positive, so we move to the right. But what happens here? This is your units. The unit is negative, so we move to the graph. What is the verbal description here? Graph moves 2 units to the left. Do you guys get it? Avyukt, are you on the same page as me?
Yeah.
Shriya, are you on the same page as me?
Yeah.
Okay. Okay, now how about this? I'm not going to draw every graph that you're going to do at home. How about this graph? How will you draw this graph? What would happen here? What are the transformations? Tell me the transformations. We have to list out the transformation. What are the transformation? Lasya, you want to say, ma?
Sure. It goes up 3 and
Up 3 and then
goes 1 to the left.
1 to the left. So what coordinate will change because of the up 3? Up. The graph goes up. That means what? It will affect which coordinate?
The y coordinate.
Y will become y plus 3. 1 to the left means it's going to affect the x coordinate. X is always left and right movement, right? 1 to the left means what would you do? X minus 2. Meaning you're going to subtract 2. 1 to the left means, okay, 1 to the left means what happens? X minus 1, right? So what will we do? It moved to the right or left, Lasya? Sorry, I did not hear you. What was that?
Left. Moves to the left 1.
X is the opposite, right, ma?
Wait, right, yeah, right 1.
I got confused. Okay. Yeah. So it moved to the, so it moves to the what? Right or left?
Right.
Right. So plus 3. This is a plus 1, right? So let me write it down. Let me write down the verbal description. Then only you'll get used to. So it is move up by 3. And then this is right by 1. In that case, y coordinate you will add 3. X coordinate you will add 1. Did you get it, guys? In the transformed table, the process would be for x value x plus 1, minus 3 plus 1, minus 1 plus 1, 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1. If you follow this process, you will never end up with a wrong thing in a transformed graph. Okay, there are so many kids that suffer if you don't know what is the process, how to do it. Okay, every transform graph, I would follow this process throughout in algebra 2. For every transformation that we discuss, we will do a parent table, we will put the xy values, and we'll do a transformed function. This is the transformation of this function. H of x is transformed, right? So we'll do a transformation function. Then we'll put an x and y for the transform function. So here, the way, if it is a transform graph, let's say in algebra 2, really, now I'm doing some samples, right? So the way we'll do is we'll put parent, we'll put transform function. Okay, this one will have x and y value. Here you need to be careful when you write the x and y value. So here I would write it out as x plus 1, y plus 3. So when I write down the values, it's very easy for me to link these, you see. So I can write it down and then I can plot this for the transform function. Did you guys get it? So this would be minus 2, 0, 1, 2, 3, 4. The process for the y would be y plus 3. First of all, I need to know this one. 0, minus 3, 1, 0, 0, 1. So process would be 0 plus 3, minus 3 plus 3, 1 plus 3, 0 plus 3, 1 plus 3, 0 plus 3, 3, 0, 4, 3, 4, 3. Now what graph I'll plot? Minus 2, 3, minus 2, minus 2, 3, 0, 0. Then what? 1, 4, 2, 3, 1, 2, 3. I'll become blind, I think. 2, 3, 3, 4, 3, 4, and then one more. That's all. So here the graph is going to be like this, and there is going to be a circle, semicircle. So what happened to the graph when you think about it? See here, this point moved up by 3 units and then it went right by 1. Do you see? This point moved up by 3 units. What is that point? This point moved up by 3 units, then went right by 1. See? Moved up by 3 units and went right by 1. Do you get it? So like that you should be able to map. Let's consider this one point. Any point, okay, moved up by 3 units. So it went 1, 2, 3 here, and then moved right by 1, right? So this is 1, 2, 3, 4. I'm sorry, 1, 2, 3, 4, 4, 4, and then this is as well 1, 2, 3, 4. See this point, right? Is it 4 comma 4? Yes, yes, 1, 2, 3, 4, 1, 2, 3, 4. Make sense, guys? Are we all on the same page? Okay. Okay, how about this? Okay, if suppose I give you this, do you remember from algebra 1? Let's see. This one. What is this, guys? What is that? Huh?
Reflection.
What is that?
A reflection.
A reflection on what? There are two things, right? Okay, let me tell you. Okay, let me tell you, please. Okay, this can be this. Okay, or this is always transform function. Okay, this is my parent. Okay, or it can be h of minus x. Now we are going to decide which reflection, where either it can reflect on x-axis or y-axis. Okay, but how do we decide? Take a point 2 comma 1. Okay, if you take a point 2 comma 1, this is the x-axis. Reflected on x-axis, what would be the point? What would be the point if I reflect this on the x-axis? Shreya, you want to say?
2, -1.
Which coordinate changed?
Y.
Y. See? Y negates. You get it? Reflect the same point. This is the easiest way to remember. Even if you forget, you can find this out later. Reflected on the y-axis, what would be the point of view?
-2, comma 1.
Negative 2 comma 1. Which coordinate negated?
X.
X negated. So if it is a reflection on the y-axis, you will see x coordinate getting negated. If it is a reflection on the x-axis, you will see y coordinate getting negated. Here what is getting negated?
The y.
Y. Y is h of x. The y value is h of x, right? That gets negated. So y value gets negated. What would I call this transformation verbally? This is a reflection on x-axis. This one, do you see x coordinate is getting negated? It is a reflection on y-axis. Did you get it, guys? Okay. Now, when you plot this process, right? Let's say this is the process. Meaning. Let's write it down. I really want you to try both of this. First, let's do minus of h of x. So, which coordinate will you negate and write for this one? Meaning, which one will remain the same? We won't have this. Which one will remain the same? If I want to graph this function, which one will remain the same? Which coordinate will change?
The x value is the same, the y value changes.
Correct. X value is the same. There is no change. Did you see? But the y value negates. So x value, I'll write it from here. Y value, I'll negate whatever I write here, right? Y value 0, -3, 1, 0. What did I do? 1, 0, 1, and then a 0. So here what did I do? The x value, I write it down the same thing. But since I have this, I will negate this and write 0, 3, -1, 0, -1, 0. Make sense, guys? Srishti, are you with me?
Yeah.
Okay. Now, I really want you to plot this, okay? It's okay, even if we take time, it's okay. Let's plot it. We'll do both because you'll understand it better. Now minus 3 comma 0, minus 3, 1, 2, 3, minus 3 comma 0, then minus 1 comma 3, minus 1 comma 1, 2, 3, then 0 comma minus 1, minus 1, 1 comma 0, then 1, 2 comma minus 1, then 3 comma 0. Okay, let's draw this function. Let's draw it nicely in C. Let's draw this function. It goes up, comes down, goes up, then comes down, and then this is the circle. What do you think, guys? What happened? It reflected on which axis? It's a reflection on, see this function, compare this function.
Axis.
It's a reflection on x-axis. Did you see that? That's why it's a reflection on x-axis. Did you get it? Now suppose the other one. I'm going to do both, please. Even if you're going to get bored, it will remain in your memory. How about I have the x and y, but this time you know what I'm going to do? I'm going to do h of minus x. So which value should I negate? What value changed? Our original function was h of x. I'm writing another function. This one, here I put a minus x. So which value negated?
The x value.
X value negated. So this would be 3, 1, 0, minus 1, minus 2, minus 3. And y value will remain the same. Y value did not change at all. Okay, whatever you change in x, we don't know. But y value remained the same, right? It's h of minus x. X value negated, but y value remained the same. Minus 3, 1, 0, 1, 0. Now 3 comma 0. 3 comma 0 means x-axis 3, right? 1, 2, 3 comma 0. 1 comma minus 3. 0 comma 1. Then minus 1 comma 0. Then minus 2 comma 1. Then come back. Oh wow. So the circle came here and it went up like this. So how did it reflect? What happened? Where did it reflect? This went where? Went here. Right? Right? Then this one remained the same like this. And then it reflected. Then it came here. Then it went here and stopped. See? That's what is the graph. So it was a reflection on the... Reflection on which axis? Guys.
The y-axis. The y-axis.
Y-axis. So this is a reflection on y-axis. Guys, did you get it? Okay. Let me see. I really want you to be able to do... Okay. I don't know. See this one? Let me know whether you understand or not. Let's see. I don't think you can do this. I don't know if you can do. Let's see. I'll mark down the questions that you can do. Okay. Would you be able to do this? What is this? If it is 2 times h of x, what will happen? You describe it. What is happening? Which value is changing?
The y.
Yes, y value is changing. So what should you do to the y value?
Multiply by 2.
Exactly. Y value will get multiplied by 2. So you can draw the graph and see. If the y value gets multiplied by 2, what do you call it verbally?
Vertical stretch.
Stretch. Good job. Okay. So, guys, are you learning or are we revising the old ones? How is it for you? I always have the doubt. Are we revising or are you learning new things? Johan, tell me.
Yeah, I'm learning a little bit too.
Okay, a little bit too. Okay. No, but anyway, this exercise is very, very important for whatever functions you take in later. Okay. So that's nice to know. How about somebody else as well answers? Srishti, you're learning something?
Yeah, it's like revision, but also learning at the same time.
Okay. Okay. We'll do more complex ones next week. Okay. For this week, I'll note down what you can do. Do that alone. Make sense, guys? Okay. I'll stop here. Any questions for me? Okay. Then I'll say bye. See you all next week. Enjoy the summer. Bye, guys.
Thanks, Priya.
Bye, man.
Bye, guys.